at Nansemond River, we started First Robotics in the fall of 2009, where we started what we call pre-season in the fall, and we learn about the organization, we learn about how to use the tools and how to program and what makes up all the different aspects of the robot. In the winter is when we really get into the gist of the competition. The first weekend in January every year is when we find out the game that we will be playing, and we are given a big, huge box, or what they call a kit of parts, and we figure out what to do to be able to play the game. The students use strategy to figure out what they want. They design it, they fabricate it, and they program the robot, and they have 6 weeks to do that. We then go to competition where we are paired up with 60 different teams across the United States where we compete, and we fill up the VCU Siegel Center and we have a blast. It's really loud. One of the things that Dean Kamen is well known for saying is it's like the Super Bowl for nerds. It's a big, huge, loud, inviting, exciting atmosphere where the kids have all created these different designs to fulfill a task, and they get to see it actually happen, and it's a really neat opportunity for those students.
I got involved with robotics because I'm in the Project Lead the Way program here, and it's for engineering, and a lot of this is like you get to work with your hands and actually work out real life problems, and it was really interesting to me to actually be able to do something and actually see an outcome.
Through the process of designing and building the robot, the students are 100% involved. We have students that learn about electrical systems, so they're splicing wires from things that normally plug into a wall, and they're soldering them to new wires to be able to actually work on our robot through the power distribution panel. Our students are actually the ones that design the program to make the robot work. This year's robot has pneumatics on it, so they have to be able to program the pneumatic cylinders to work at the push of a button. They use different controls, so they have to be able to tell the robot how they want it to work. They also even program the robot to work what's called autonomously, so it works without someone pushing controls to make it move. We also, this year we were lucky to have some of our parts manufactured by Shadle Sheet Metal on Saratoga Street in Suffolk, and we also build some of the parts ourselves, and the students design the whole thing, how it looks, what it's going to do, and they assemble it themselves.
The robot, when we finish, is supposed to be about 37 inches tall, and it's going to have an upper frame that will catch the yoga ball that we have to catch, and it will have a pneumatic arm that will push the ball out from underneath, and the rest of the frame will just be tall. It'll have shelving on the inside, and it'll be covered with Lexan to protect everything.